Let us now discuss about the most important section in polarization of light, that is Malice Law. In Malice Law here we can write, this is basically related to the intensity of light when it passes through a Polaroid or a polarizing device. Here we can write that a Polaroid only allows those vibrations to pass through it which have their vibrational plane along the transmission axis of Polaroid. Say if this is a Polaroid, this is a symbol we use for a Polaroid, and say this is its transmission axis on which one an unpolarized light is allowed to incident, in which the light is having vibrations in all planes like this. The light is coming up. When the light is incident onto the Polaroid, only the vibrational planes which are along the transmission axis are passed through it, and only those vibrations are coming out of the Polaroid, rest are absorbed by the Polaroid. Now this is the polarized light which is coming out from a Polaroid. This is the symbol we are using for Polaroid. Now in this situation, if we talk about the intensity of Polaroid, if the incident intensity is I0, the light which is incident on Polaroid, the light which is coming out will be I, and certainly it will be less than I0. How the intensity of light is analyzed? Let's analyze it with the help of a mathematical rule which we call Malice Law. And in next section we'll study about the drop in intensity when an unpolarized light transforms to polarized light when it passes through a Polaroid. Here we can write when a plane polarized light with amplitude A0 incident on a Polaroid over the vibration plane at angle theta to transmission axis, then the amplitude of vibration in transmitted light will be A cos theta. This is what we term as Malice Law. In this situation here, you can understand it with the help of a diagram. Say if we are having a polarized light in which the oscillations are only in one plane, and when this polarized light incident on a Polaroid of which the transmission axis is at an angle theta from the plane of vibrations of the polarized light. So this is the Polaroid which is placed by tilting at an angle theta. So when these vibrations will incident over here, say if it is of amplitude A0, then this will have two components. One will be A0 cos theta and other will be perpendicular to it, which is A0 sin theta. Now in this situation, this A0 cos theta amplitude will be along the transmission axis of Polaroid. So this will pass through the transmitted light. This will transmit through the Polaroid, and in transmitted light only the vibrations which are along the transmission axis will be coming out, and these are having amplitude A0 cos theta because A0 sin theta is perpendicular to transmission axis, so it will be blocked. So this is what we term as Malice Law. If we talk about the intensity of light in this situation, let's continue on the next sheet. So here let's continue our discussion on intensities of incident and transmitted light when it passes through a tilted Polaroid. Here we have discussed that when a Polaroid is tilted at an angle theta to the incident plane of the polarized light, the transmitted amplitude will be the component A0 cos theta only. So if incident intensity of light is I0, it can be written as K A0 square. If E0 is the amplitude of polarized light, then certainly the transmitted intensity can be written as k times A naught cos theta whole square, because we know the intensity of light is directly proportional to square of amplitude. So here the transmitted intensity we can write as k E naught square cos square theta, which is I naught cos square theta. This is the mathematical form of Malice Law, which is called Malice Law equation. And in this situation here we can see if theta becomes pi by 2, that means if a Polaroid is placed in the path of polarized light such that its transmission axis is at 90 degree or perpendicular to the plane of oscillations of polarized light, the transmitted intensity will be 0 or no light will pass through it, because all vibrations are perpendicular to the transmission axis of Polaroid.